So in 2.2, we're going to start off with something called the difference quotient. Now the difference quotient, I'll just give you a brief background on it. It leads into finding slopes of curves in calculus. But for right now, we need to be able to do the algebra behind it, because if any of you are planning on doing engineering or anything like that, you'll be needing calculus later on. And when you do take calculus, you're going to see this pop up, and your professor is going to assume that you already know how to do it. So it's a good lesson to have in here. No, it's more than just what I'm showing you. But this is the hardest part of it. The easier part of it is the canceling stuff out with limits. So, again, it has this f of x plus h in it minus f of x over h. And the f of x plus h, we're going to treat a whole lot like we did this f of x plus 2 that we dealt with earlier on. So we're going to figure the difference quotient out for f of x equaling to negative 2x squared minus x plus 3. Yeah, just plus 3. Now, I'm going to do some work down here to the side, just getting you used to working with the formula. If I said we have f of negative 3, we would simply say it's negative 2 times negative 3 squared minus negative 3 and plus 3. I'm not going to simplify that out because that's not the depth of what's going on here. But now what if I say we've got f of n? Well, f of n is negative 2 again. I'm plugging it in everywhere I have x. So it's negative 2n minus n and plus 3. So that's how you deal with f of n. This formula up here has f of x plus h. Yes?
Is that supposed to be squared?
Thank you. It is supposed to be squared. That is very important. All right. So this formula has in it an f of x plus h. So I need to know what is f of x plus h. Well, it is negative 2 times x plus h squared minus x plus h and then plus 3. It's just like earlier when we had x plus 2. We had x plus 2 squared minus, I think it was 2 times x plus 2 or whatever. We handle it the same way. The only difference is we don't have any numbers in this. It's just letters. So, for this particular problem, the difference quotient says I'm going to take f of x plus h, which for this particular problem is negative 2 times x plus h squared minus x plus h plus 3. Now, what does it say for us to do with f of x plus h in the formula? We're supposed to do what to it? Say that again.
Subtract f of x.
Just subtract f of x from it. So let's subtract f of x from it. So it's minus negative 2x squared minus x plus 3. And then it's all over h. All right. So we start off here by squaring x plus h, so it's negative 2 times x squared plus 2x plus h. We've squared it, we don't need to square on it anymore. All right. Then it's minus x plus h plus 3. Now, when I was going through school, we didn't have these expo markers to change colors. Our teacher just had to scratch in the stone a little bit harder if she was trying to show a different color. Every once in a while, if she got to a third color, she had to prick her finger for blood to get a third notation up there. So anyway, times were hard when I was going through. So anyway, I'm going to keep going. So we've got negative 2x squared minus 4x minus 2h. I'm sorry, I missed this. It's not 2x, it's 2xh. I blew this problem totally, and then this is h squared. I apologize. Squaring this binomial, it's x squared. 2 times the first times the second, 2xh, and then the third term squared is h squared. All right, so this is minus 4xh, right? And then minus 2h squared. All right. And then distribute the negative into the next portion, so it's negative x minus h plus 3 minus 2x squared minus x plus 3 all over h. Now, I mentioned that this leads into calculus. And in calculus, we do more than just polynomials with this difference quotient. For the purposes of college algebra, all of our problems are going to be polynomials. And for the purpose of polynomials, when we get to this step right here, if it doesn't have an h in it, and we have done it correctly, it should cancel out. So let's see if we have done it correctly. I did not distribute incorrectly. Good grief, I'm embarrassed to have put this problem up here. This was negative 2x squared, it didn't carry the negative down with it. So this becomes plus 2. So I'm glad I did have that thing to check on. And I would love to sit here and tell you I made those mistakes on purpose, but I just messed up. Okay, so let me make sure everything else is right. Negative 2 and x squared is negative 2x squared. Negative 2 and positive 2xh is this. Negative 2 and h squared is negative 2h squared. Distributed that negative. Okay, I'm good the rest of the way through. Wow. All right, let's keep going then. Negative 2x squared and positive 2x squared cancel out. Okay, nothing cancels with 4xh. Nothing cancels with negative 2h squared. Negative x and positive x go away. And then positive 3 and negative 3 go away. All right. So now what are we left with? Well, we're left with negative 4xh minus 2h squared minus h over h. All right. Now, one more thing can happen here. Does anybody see does anything jump out at you from what's on the board here?
Can you take h out or something?
Yeah. Every term has an h in common. So I'm going to factor an h out. So it's negative 4x minus 2h minus 1 over h. Those h's go and play with the dodo bird. So we're left with negative 4x minus 2h minus 1 as our solution. Now, that doesn't perfectly give us the slope the way it is set up here, but it's the hardest part of finding the slope in calculus. So, again, walking through what we did one more time. This is again called the difference quotient. The formula, which you're going to need to know, it's not going to be something that that's going to be given to you. But it is f of x plus h minus f of x over h. That formula works for every difference quotient problem. After that, it's just a matter of plugging in. Now, notice what I did. When I plugged in, I went off to the side and first solved for f of x plus h. That just helped me organize my thoughts a little bit. So I was able just to go directly up to here and plug this in where I had the f of x plus h. Where I had the minus f of x. I did my minus f of x. And then I worked it through there. And I've been doing this for several years, and you saw how I easily made that careless mistake up there. It's very easy to make a careless mistake with signs, so just be careful on that. Are we okay to keep going? Again, that is the difference quotient. Now, the next thing is a piecewise function. That's actually hyphenated when written out. I didn't do that because I'm trying to squeeze everything on the board. And on a piecewise function, you're given a function that's broken down into multiple equations typically, and with that, the domain that is chosen, or the domain that you use, is specified the way the equation is set up. So let's say we have the equation h of x, and it is equal to, and most of you have seen piecewise functions before, x plus 4 or negative x plus 4. Oh, now I'm going to put x plus h everywhere. And this is if x is greater than or equal to negative 4. And this is for if x is less than negative 4. The majority of the time, piecewise functions are set up. They're set up to where the lesser domain values are on top. I don't know why this one's written like this, but it's still workable. So let's find h of negative 5 h of negative 4, and h of 0. All right, so looking at negative 5, this is my domain value. So according to my equation, which one does it match? Is negative 5 greater than negative 4? Is it less than negative 4? Less than negative 4. So I use the bottom equation for this one. So it's going to be the negative of negative 5 plus 4, which is going to be the negative of negative 1, which is Starts with a W. 1. All right. Some of y'all can't spell. All right. H of negative 4. Which equation do I use? The top one or the bottom one? Is it greater than or negative 4 or less than negative 4? Top one, right? Because it's the or equals one. So in this one I get negative 4 plus 4, which is 0. Now it just so happens, if you'd worked this problem incorrectly, you still would have gotten the same answer. But it is the top one you should plug in. And finally, h of 0. Which one of these equations would we want to deal with here? The top one again. So it's 0 plus 4, which is 4. So again, piecewise equations, look at what you're solving and see which domain it fits to choose the equation that you want to use. Are we okay to keep going? All righty. Now, when we talk about numbers, numbers are either odd or even. If you're talking about integers, I should say. Negative 4. 3. They're either odd or even. But in functions can be odd, even, or neither. And the majority of functions that you work with are neither odd nor even. But odd and even functions, if you run into these have special characteristics to them. An even function. An even function is a function where f of x equals to f of negative x. An even function, if graphed, reflects about the y-axis. Okay. Thanks. I'm going to say just go when I'm finished with this. So from this, we're going to learn how to test them in just a minute. Odd functions, the negative of f of x is going to equal to f of negative x. The negative of f of x is going to equal to f of negative x. Now, this one does not reflect about the x-axis like you might think it is. And the reason we know that is if a function reflects about the x-axis, it's not a function. Because if you take an equation reflected about the x-axis, you wouldn't pass the vertical line test. You would have x values that corresponded with more than one y value. But it is going to reflect about the origin. So, let's look at an example here. We're going to determine if odd even, or neither. First equation let's look at, I want us to look at f of x equals x squared plus 1. The second equation I want us to look at is f of x equals x cubed plus 1. And then the third one I want us to look at is f of x equals x cubed plus x. All right, so starting with x squared plus 1. Now I said we're going to use this checklist to see whether your function is odd, even, or neither. So I'm going to basically solve f of x, the negative of f of x, which is very easy. Once you solve f of x, you just take the negative of it. And then f of negative x. Now, for this, I'm going to pick a random number. I don't usually like using 1, but I'm going to go with 2. All right, so what is f of 2 for this first equation? Well, it's 2 squared plus 1, right? Which is 5. Are y'all with me? Okay. The negative of f of x is just negative 5. Now, what is f of negative x? Well, it's going to be the negative of 2 squared plus 1, which would be what's negative 2 squared? 4. And 4 plus 1 is? So which two equal to each other?
The first and last ones.
The first and last one. So f of x equal to f of negative x. So what are we looking here, odd or even? Even. All right. Now I'm going to come out here to do the next one. All right. What is f of 2? Well, it's 2 cubed plus 1, right? And what is 2 cubed? 8 plus 1 is 9. All right, what is the negative of f of 2?
Negative 9.
Negative 9. And what is the negative of what is f of negative 2? Well, it's negative 2 cubed plus 1. What do I get when I cube negative 2? Get negative 8, right? And what is negative 8 plus 1?
9.
Negative 7. So, from that, what are equal? None, right? So this would be neither. So this function here is neither odd nor even. All right. Now on to the next one. What is f of 2? What is it? The negative of f of 2. And what is f of negative 2? Okay, so what is f of 2 here? Well, it's 2 cubed plus 2, right? And what is 2 cubed? 8. 8 plus 2 is 10. So the negative of f of 2 would be negative 10. And f of negative 2 is going to be negative 2 cubed plus negative 2. Negative 2 cubed is negative 8. So it's negative 8 minus 2. And what is negative 8 minus 2? Negative 10. So in this case, which two were even? I mean, which two were equal, not even, huh? The negative f of x and f of negative x. So what kind of function do we have here? I. Are we okay here? Now, graphically, let's look at it. We could have something that looks like this. We'll pretend that I can draw. This would be an example of something that reflects about the y-axis. So this would be an even function. I'm going to graph the cube root of x. Yeah, you can go now. The cube root of x looks like this. This function reflects about the origin. And as you see, f of the value, if you take the negative of it, it would flip down to here. It would equal to the negative of that f of value. So that's what it looks like outside of that. And the last thing we're going to do is talk about relative extrema. Now, relative extrema deal with relative maximums and relative minimums. Basically, if you can, and this is a calculus definition, but they put it in here, but if you can create an open interval that has a lowest point or a highest point, then that is a relative minimum or a relative maximum. So this point, I could create an open interval in which this point is the highest point. See, I could go from here to here. And from here to here, that is the highest point. So I have, let's say that this is the point negative 1, 4, okay? Well, the relative maximum is at negative 1. So if it asks, where is the relative maximum? The answer is negative 1. If it says, what is the relative maximum? You would say it is 4. So what it is the range value. Where is it is the domain value. So this point right here, I think y'all could see would be a relative minimum because I can create an open interval in which it's the lowest point. Let's say that this is at 4, negative 2. The relative minimum is what? Listen to what I asked. The relative minimum is what? Negative 2. Where is the relative minimum? So, that is section 2.2. Y'all can go ahead and be able to do both. Like I said, when we come to class Friday, we'll do quiz 4.